of the table because of the normal reaction. Otherwise, the gravitational force will be the only force acting on this object in the downward direction.
So that is equal to mass times acceleration.
So let us take A1. A1 is the horizontal acceleration of the surfaces in contact, point of contact. You draw normal. Okay, you draw normal perpendicular to one of the surfaces. The mass of the person actually did not increase, but the reading. In the last class, we were talking about the gravitational force or the weight of an object. The next force in our list is the normal reaction. What is normal reaction? When two objects come in contact with each other, if one exerts force on the other, so this force is called a normal reaction. See, most of the interactions you have with objects around you are basically normal reaction only, right? When you want to push an object, right? If you push an object, so you exert a force on the object, so that is one form of normal reaction, right? So it is because of this normal reaction between your hand and that object, so that the object moves, right? So now, see, this normal reaction is also one form of electromagnetic force only. See, this object is kept on this table, so this object does not penetrate the surface. It doesn't pass through the surface of the table because of the normal reaction. Otherwise, the gravitational force will be the only force acting on this object in the downward direction. So against the gravitational force, the surface exerts a force in the opposite direction. So this force is called a normal reaction. So it is also an electromagnetic force only, right? See, we know that basically any matter, right? Generally, objects around you basically consist more of empty space than the actual matter itself, right? Even you consider an atom, right? Atom consists of more empty space than the actual matter. So it is natural for one object to pass through the other. So that is prevented because of the electromagnetic interaction between the subatomic particles like the electrons and protons, right? So this is also one form of electromagnetic force only, right? So this normal reaction. So there are few points about normal reaction that you have to remember, right? Simply, when two surfaces come in contact with each other, so one exerts force on the other, so that force is called a normal reaction. If this object exerts a force on that object in return exerts equal amount of force in the opposite direction, right? By Newton's third law, so this force is equal in magnitude. So the normal reaction between these two objects, right? So that these two normal reaction, right? Normal reaction due to one object on the other, and that object on this object, so these two forces are equal in magnitude but opposite in direction. Second point is, see, the direction of the normal reaction. So this normal reaction is perpendicular to the surfaces in contact. When two surfaces come in contact, so this normal reaction force, right, is perpendicular to the surfaces, right? But when just one point of contact is there is only one point of contact, then at that point, you can draw normal to the surface. What is normal? That is a perpendicular line. In mathematical sense, the normal line is a line perpendicular to the surface, right? Like this. You draw a tangent. Otherwise, at that point of contact, you draw tangent. And you draw perpendicular line to the tangent at that point. So that perpendicular line is called a normal. So our normal force is along the normal line, right? That means it is perpendicular to the tangent at that point. Sometimes one of the surfaces is not properly defined, right? So it is only one point of contact. This surface is not smooth. At that point of contact, at least we can draw normal to one of the surfaces, right? So this normal, so this is the direction of the normal, right? So generally, simply remember these things. So what is normal reaction? When two surfaces come in contact, if one exerts force on the other, so this force is called a normal reaction, and the direction of normal reaction, so that is perpendicular to the surfaces in contact, right? So that's all. These are the only points that we are going to use here today, right? So no more theory, so only these points, and in addition to that, we are going to use this Newton's laws of motion, right? So let us use this to solve some questions, right? Let's start with some simple questions, okay? A force F acts horizontally on the blocks given in the figure. If N1 is the normal reaction between the ground and the block of mass M1, and N2 is the normal reaction between the blocks, and A is the acceleration of the blocks, then here we have two blocks of mass M1 and M2, and there is a force F acting on M1 in the horizontal direction. Note that the force F is not acting directly on M2. F acts on M1. In turn, M1 exerts a force on M2. So that force between the two blocks is called the normal reaction between the blocks, and that normal reaction is what we need to find. We also have to find the normal force between the block M1 and the ground. We need to find the acceleration of the two blocks also, right? So let us find all these values one by one using Newton's law, that's all, right? So let us write the equation of motion for the block M1. See, the block M1 or M2, so these blocks move only in the horizontal direction. That means they are in vertical equilibrium. So the total force acting on these blocks in the vertical direction, right? The total force is 0. Do you understand? Because these blocks are in vertical equilibrium. So let us write all the forces acting on the block M1 in the vertical direction. Alright, so first let us write M1. So M1, what are the forces acting on this M1? Only in the vertical direction. There is a gravitational force acting in the downward direction. So gravitational force. So let us consider only the vertical. Alright, so only in the vertical direction we will write all the forces. Now mg, right, that is the gravitational force, m1g. That is acting in the vertically downward direction. So we have taken the vertically downward direction to be positive. We can take any direction to be positive, vertically downward direction positive. So against the gravitational force there is a normal reaction in the opposite direction. So minus n1. So we call that normal reaction n1. So this is the total force acting on the block M1 in the vertical direction, right? Mg in the downward direction and normal reaction in the opposite direction, right? But that must be equal to 0 because this object is in equilibrium, right? Vertical equilibrium. So no acceleration in the vertical direction. The acceleration is only in the horizontal direction. So total force in the vertical direction is 0. Okay, so that's it. That gives you the value of N1. So N1 equals M1G. So that is the normal force between the block and the ground. Okay, done. Now we have to consider the other direction, right? Horizontal direction. So in the horizontal direction, what are the forces acting on the block M1? See, the force F acts on M1 in the horizontal direction, right? Take this to be the positive direction. So F is one force acting on the block. And also M1 exerts a force on M2. So that is a normal reaction. Then by Newton's third law, there will be a reaction force. So M2 also exerts equal force in the opposite direction, right? So what are the forces acting on M2 in the horizontal direction? So one is the force F itself, and then the normal reaction due to that block in the opposite direction. So that is N2. Okay, total force in the horizontal direction. So that must be equal to, by Newton's second law, it is mass times the acceleration. So mass of the object is M1 multiplied by the acceleration. Okay, so this is the horizontal direction. Okay, done. Now you consider the other block, right? M2. Now consider the horizontal direction only. So what are the forces acting on M2? The only force acting on M2 is the normal force due to the other block, right? So that is N2, right? So N2 is the only force. So we are only considering the horizontal direction here. So N2 is the only force acting on that block, okay, in the horizontal direction. So that must be equal to mass times the acceleration. So that is M2 acceleration A. See, we are using the same acceleration A here also, because these blocks move together, which means they will have the same acceleration. They are not separated. So they move together. So the acceleration of that block, the acceleration of this block are same. Okay, so that's also M2A, same value. Now we can solve these two equations to get the value of whatever required. N2 is required, just solve them. So first we can add them to get the acceleration. So just add these two equations. What do you get? So F, N2 gets cancelled. So that equals M1 plus M2 multiplied by A. So that's all. That gives you the acceleration. It is F divided by M1 plus M2. So this is the acceleration of the block. Both the blocks move with the same acceleration A. Substituting this acceleration here in any one of the equations, we get the value of N2. So substitute in this equation. So N2 equals, so M2 multiplied by A. So it is M2 F divided by M1 plus M2. So that's all. So this is our required normal reaction between these two blocks, right? So that's it. Now to find this acceleration of these two blocks, we can directly also write without considering these equations separately. See, these two blocks always move together. They are never separated. So we can consider these two blocks to be one system only. So you put these two objects together, consider that as one system. Okay. So that means what is the total force acting on this system in the horizontal direction? Only force is F. F is the only force acting on this system, because that N2 is the internal force, right? The whole system has only external force F in the horizontal direction. That means by Newton's second law, the force equals mass times the acceleration. What is the mass? M1 plus M2 total mass multiplied by the acceleration. That gives you acceleration F divided by M1 plus M2. So this way also we can find directly the acceleration of the two blocks. Okay, so that, but anyway we have to find the normal reaction also. We have to do this method. Suppose you want only the acceleration, we can use that method also, right? So this is the acceleration F divided by M1 plus M2, and also we have got the normal reaction between the blocks, and also this N1, which is the normal force between the block and the ground, right? So this is the answer. a force of magnitude 4 and pushes a block of mass 20 kg at an angle 30 degree to the horizontal. The acceleration of the block and the normal reaction between the block and the ground are given by. Here we have just one block, but the force here is not acting in the horizontal direction. It is making some angle, say 30 degree with the horizontal, right? So the force is acting in some direction, but the object is constrained to move only in the horizontal direction, right? So whatever is the direction of the force, the object will only move in the horizontal direction. Okay, yes. Now we have to find the component of the force in the horizontal direction. Because the object is moving only in the horizontal direction, we want the effect of the force only in the direction of motion. So let us take the component of the force in the horizontal direction. We also take the component of the force in the vertical direction to find the normal reaction. So let us take the two directions, right? So let us first consider the horizontal direction. So in the horizontal direction, so what is the force acting in the horizontal direction? So that is the component of the force in the horizontal direction. So that is F cos 30 degree. So that is the component in the direction making angle 30 degree. So F cos 30 degree, that is the total force. So that must be equal to mass times the acceleration. Okay, so mass times the acceleration. Okay, so that's all. This will give you our required acceleration because force is known. So that is given to be 4 Newton. So the force is 4 Newton multiplied by cos 30. So we know root 3 by 2. So that must be equal to, so the mass of the object is 20 kilograms multiplied by the acceleration. So that's it. That gives you a required acceleration. So that equals, so 2. Okay, so that's it. So root 3 divided by 10 meter per second square. So this is the acceleration of the block in the horizontal direction. Okay, done. Now we have to find the normal reaction. So the normal reaction in the vertically upward direction, that's what we need to find. So let us consider the forces acting in the vertical direction. So what are the forces acting in the vertical direction? Of course, there is a gravitational force in the downward direction and normal reaction in the vertically upward direction, and we also have the component of the force F in the vertical direction. In the last case, there was no component in the vertical direction because the force was acting in the horizontal direction, no vertical component, right? Cos 90, that is 0. So no vertical component. But here, this force F also contributes to the vertical motion, right? In the vertical direction also it has some component. So what is the total force? Let's take the horizontal direction to be, downward direction to be positive. So mg is the force acting in the vertically downward direction minus the normal reaction acting in the vertically upward direction, and also there is a vertical downward component of the force, right? Yes, now that is minus, right? So downward component, that means plus F. So here this angle is 30 degrees. So that means the vertical component is sine 30, right? Because not horizontal, vertical, right? So sine 30. Sine 30 degrees. So that must be equal to 0 because there is no vertical motion. So the total force acting in the vertical direction, so that must be 0. So that's how this will give you our required normal reaction. So let us substitute this value. So the mass of the object is known 20 and g. So g can be taken as 10 minus n plus this is 4 multiplied by sine 31 by 2, so that equals 0. So this gives you our required value of n. So this is 200 minus 2, sorry, 200 plus 2. So 202 Newton. Okay, so that's all. So this is our required normal reaction. You understand? So the total force in the vertical direction, not only the normal reaction and the gravitational force, we also have the component of the force in the vertical direction, right? Total force in the vertical direction is 0. That gives you our required normal reaction. Okay, so that is the answer. A time varying force F equal to 4t at an angle 30 degree to the horizontal pulls a block of mass 5 kg. The acceleration of the block 5 seconds after it loses contact with the floor is. This question is similar to the last question. The only difference here is that the force is a variable force. So it is 4 times t. That means at different point of time we have different magnitude of the force. So this force makes some angle 30 degree with the horizontal. So obviously we have to consider the two components, right? Horizontal component and vertical component, right? So almost similar to the last question. So let us first write the equation in the vertical direction. Alright. So in the vertical direction, what are the forces acting? So vertical direction. See, let's consider the upward direction to be positive. So any direction doesn't matter. So in the upward direction, the component of the force in the vertical direction, F, with the horizontal, the angle is 30 degree. That means F sine 30. So that is the vertical component, or cos 60. Okay, F sine 30. So F sine 30. So that is the vertical component of the force, and also there is a normal reaction in the vertically upward direction. So plus n. and also the gravitational force in the vertically downward direction, so minus mg, so that must be equal to 0. Alright, so this is the total force, so that is equal to 0. Okay, now so let us find n. Okay, substituting the value of f, so f equal to 40, so 40 sine 30, sine 30 is 1 by 2, so that means 2t plus n minus mg, right? So the mass of the object is 5 kilograms, so 5 multiplied by 10, so 50, so that equals 0. So this gives you n equals, okay, 50 minus 2t. See, this is the normal reaction. So generally when the object is moving, now when at that particular point of time when the object loses contact, when the object loses contact with the ground, there is no normal reaction. The normal reaction is due to the ground. So when it loses contact, there is no normal reaction. This normal reaction becomes 0. See, when it loses contact, when it loses contact with the flow, right? So the normal reaction becomes 0. Alright, normal reaction becomes 0. So n is 0. So that means, so t is equal to 50 minus 2t is 0. So t is 25. So 25 seconds. So that is the time after which the object loses contact with the ground, right? So 25 seconds. Now we need to find the acceleration after 5 more seconds, right? Which means 25 plus 5, 30 seconds. When the time is 30 seconds, what is the acceleration? But the moment it loses contact with the ground, there will be two acceleration in two directions, right? One in the horizontal direction, one in the vertical direction. See, as long as the object is moving only along the ground, then we have only one acceleration, which means in the horizontal direction only. But when it loses contact with the floor, it is in air. That means it will have two acceleration, one in the horizontal direction, one in the vertically upward direction. Alright, so let us find these two components of the acceleration separately. Okay, yes. Now in the horizontal direction, so when t is equal to see 25 seconds plus 5 seconds, that means 30 seconds. When t equal to 30 seconds, we have to find the acceleration. Okay, so first let us find the horizontal direction. So what is the force acting in the horizontal direction? So that is the component of the force in the horizontal direction. That is the only force, right? Component of the given force. So for F cos 30. F cos 30 is the only force. So that must be equal to mass times acceleration. So let us take A1. A1 is the horizontal acceleration of the block. Okay, yes, now let us substitute. What is the force for T? But T is known already, 30. So force is 4 multiplied by 30 multiplied by cos 30. Cos 30 is root 3 by 2 equal to mass is 5 multiplied by the acceleration A1. So that gives you our required acceleration in the horizontal direction, that is A1. So what is this value? So this is 2 multiplied by 30. So 60 divided by 5. So 12 root 3. So 12 root 3 is the acceleration in the horizontal direction. Okay, done. Yes, now similarly we will find the vertical acceleration. So vertical. So what are the forces acting in the vertically upward direction? No normal reaction, because normal reaction has become 0 when it loses contact with the flow. Okay, now vertical. So the component of the force in the vertical direction, that is F sine 30 in the upward direction, and then mg in the downward direction, so minus mg. So that must be equal to the mass times the acceleration, say A2 in the vertically upward direction. Okay, now let us substitute. So F here is again same thing, 40, 4 multiplied by 30 multiplied by sine 30 is 1 by 2 minus mass of the object is 5 multiplied by 10, so that is 50. So that equals, so 5 multiplied by A2. So that gives you the value of A2. So what is the acceleration in the vertical direction A2? So this is 60 minus 50, 10 divided by 5, 2. So 2 is the acceleration, okay, 2 meter per second square. That is the acceleration in the vertically upward direction. Now what is the total acceleration? So we have the horizontal component and we have the vertical component. So we have to find the total acceleration. See, so that's simple. We know the horizontal component. So what is the horizontal component? That is 12 root 3. And we've also got the vertical component, that is 2. Now we have to find the total acceleration. Okay, so this is our required acceleration. So how to find it? So that is simple, right? So we can use the Pythagoras theorem to find. So 12 root 3 and this side is 2. Then we can use vector form, right? This is 12 root 3 I cap. I cap is the horizontal direction, the unit vector, 12 root 3 I cap and 2 j cap. So what is the magnitude of the vector? So square root of this A1 square plus A2 square, right? So that's what, so our required acceleration. So this gives you our required acceleration A equal to square root of A1 square plus A2 square. So that equals, so what is the value? So 12 root 3 square, okay, 12 root 3 square and then 2 square. So what will you get? So that becomes square root of, okay, so 144 divided by 3 and plus 2 square. So 144 multiplied by 3 plus 4. So that gives you 2. Yeah, so that is 36 multiplied by 3. 108, so 109, I think. Okay, yes, so 2 root 109. So that is the required acceleration. Okay, so we found two components of the acceleration, horizontal and vertical. So then the resultant is simply the square root of this square plus this square. So that is our required answer. Okay, yes, so that's it. A force of magnitude 60 Newton acts horizontally on a block of mass 5 kg lying on a smooth plane of inclination 60 degree. The acceleration of the block and the normal reaction between the block and the plane are given by. Here the block is placed not on the ground but on an inclined plane making some angle 60 degree with the horizontal, right? That means the object is constrained to move only along the plane, right? Not in the horizontal or vertical direction. Okay, there is a force F in the horizontal direction and there is a normal reaction and also the vertically downward gravitational force. So these are the forces acting on the block but in different directions. Now we have to take the components of all these forces in our required direction. Which direction? The object moves along the plane, so we have to take the components of all the forces in that direction only. Okay, let us take the component. For that we need the angle made by these forces with the plane. Okay, now the mg, right, the gravitational force mg makes angle 30 degree because this angle is 60 degree right angle triangle. So 30 degree, mg makes 30 degree with the incline. Similarly, and the force, that force makes what angle with the plane? So this angle is 60, so with the vertical the angle is 30, so that angle is again 60 degree. So that means, so the force makes angle 60 degree with the incline. So that's all, we got the angle, then we can take the components. Alright, so let us write the equation in that direction, okay, direction of the plane. Okay, yeah, so along the plane. So let us write the equation along the plane. Okay, so what are the forces? F is making angle say 60 degree, that means F cos 60 degree. And the gravitational force is acting in the downward direction, take its component, right, 30 degree. So minus, okay, minus opposite direction. So minus mg, yeah, cos 30 degree or sin 60, okay. So that equals mass times the acceleration. So this acceleration is along the plane, right? Okay, yes, now let us simplify this to get the required acceleration, that's it. So what is F here? So 75, okay, and substitute these values, you will get the answer, okay.
Does the block move up or down?
We don't know whether the object is moving up or down the plane, but we have to assume one of the directions to be positive. We have taken the upward direction to be the positive direction, assuming that the object is moving upwards. What if the object is actually moving in the downward direction? We will get the value of acceleration negative. We have taken the upward direction positive. Then if the object is moving in the downward direction, we will get the acceleration negative. So it doesn't matter. Initially we don't know which direction to take. So we have taken the upward direction positive. We got this equation. If you take the downward direction to be positive, you get this one. So mg cos 30 minus f cos 60 equal to ma, right? Doesn't matter. So you will get the sign of the acceleration accordingly. Okay. So now assuming that the object is moving in the upward direction, so we have taken this equation. Okay, yes, now let us simplify this. What is the force? So that is 60 Newton. Okay, so that's it. So 60 multiplied by cos 60 minus mg, so mass of the object. So 5 multiplied by 10, so cos 30 root 3 by 2 equal to m5 multiplied by the acceleration. So that will give you a required acceleration. So that equals, so 60 divided by 2, 30 minus 25 root 3. Okay, so that's all. So this is the acceleration. Is it positive or negative? So 30 minus 25 root 3. So root 3 is 1 point something. Okay, so this is a negative value, right? This value is bigger, right? So this is a negative value. So this is negative. That means we understand that the object is moving in the downward direction. But we have taken the upward direction to be positive. That's why we are getting negative sign. So if you want the positive value of the acceleration, so only the magnitude, right? So we just write the positive value. So then we can write it as 25 root 3 minus 30. Okay, both are correct, but it is negative. We just need the magnitude, so we return the positive value. So this is the required acceleration, right? So meter per second square. Okay, so that's also, that is the acceleration of the object. Now we need the normal reaction. Now we consider the equation in the direction perpendicular to the plane. Okay, so along the plane, so we have done. So now perpendicular to the plane. Okay, perpendicular to the plane, what are the forces acting? Okay, so what are the forces acting in the perpendicular direction? Okay, there is a normal reaction in the upward direction, so normal, minus the gravitational force in the downward direction. So the gravitational force makes angle 60 degree, right, perpendicular to the plane. This angle is 60 degree, so its component is mg cos 60 degree. So mg cos 60 degree. Okay, now we also have the component of the force F in the vertical direction, right? So what is its component? So that is 30 degree, right? F makes angle 30 degree with the normal. So that means F cos 30, right? Yes. Opposite direction, so F cos 30. That equals 0 because no motion perpendicular to the plane. So that means this total force is 0. Okay, yes, let's simplify this to get our required answer. So N equals mg. So m here is, right, 5 multiplied by 10 cos 60 plus f again 60 multiplied by root 3 by 2. So that's also, this is the normal, which is 25 plus this is 30 root 3. Okay, so this is the normal force. Okay, so that's also, that is the answer. Okay, and this is the acceleration of the object which is in the direction along the plane, and this normal reaction has value, this one 25 plus 30 root 3. So that is the answer. Sorry, this is 5 times the acceleration, right? So 5 times a, so 5 multiplied by a, so we have to divide this by 5 to get our required acceleration, so which is 5 root 3 minus 6. Okay, so that is the answer. The normal reaction between the two blocks given in the figure is. Here also we have two blocks, but their contact surface is not horizontal or vertical. So that makes some angle theta with the horizontal, right? Yes, that means the normal reaction between the two blocks is in the direction perpendicular to the surface. So that makes some angle, say 90 minus theta, because this angle is theta. So theta, right? Alternate angle theta. So that means that angle is 90 minus theta. So the normal force between the blocks makes angle 90 minus theta with the horizontal. Okay, yes. Now let us consider the equation for both these blocks. But which direction these blocks move? Both the blocks move together, which means they have the same acceleration, but in which direction we don't know. It depends on the force F1 and F2, whichever is the stronger force, but here we don't know. So we have to assume one of the directions to be positive. Suppose the blocks move in the forward direction, so this is the positive direction. Okay, it doesn't matter, any one of the directions we can take to be positive. Okay, yes. Now, so what is the total force acting on the block capital M? So that is, yes. Now let us first write the equation for the small m, right, block. Yes, let us write. What are the forces acting on the block M? So that is F2 in the forward direction, F2, and the component of the normal force in the horizontal direction. See, that makes angle 90 minus theta. What is its component? N sin theta, because 90 minus theta is the angle, that means sin theta. N sin theta in the opposite direction. So N sin theta opposite direction, and F2 in the positive direction. So F2 minus N sin theta, right? Yes, sin theta. This is the total force. That's all. So that must be equal to mass times acceleration. So this equals the mass of the object is m multiplied by the acceleration. Okay, yes. Assuming this direction to be positive. Now similarly, we'll write the equation for the other block also. Yes. Now let us write what are the forces acting, but this time the object is moving in this direction, so the normal reaction, so that is in the positive direction. So what is the component of the normal in the positive direction? N multiplied by, again the angle is 90 minus theta, so sin theta. N sin theta acting in this direction, so N sin theta. In the opposite direction we have the force F1, so minus F1. So that equals the mass of the object multiplied by same acceleration. See, acceleration is same for both the blocks because these two blocks are always moving together. Okay, so that means mass multiplied by acceleration. Okay, that's it. Solving this, we will get our required value of acceleration. So what we need is the normal reaction, right? So we need the normal reaction, which means we have to eliminate this acceleration. Okay, so let us substitute this acceleration here, or one of the equations. So let's eliminate this. So what can be done? So let us divide these two equations. Okay, if you divide these two equations, f2 minus n sine theta divided by n sine theta minus f1 equals m divided by m. Okay, so we can find the value of a from this and substitute here, so whatever. So let us simplify this. So yeah, m f2 minus this one, n multiplied by m sine theta, so that equals, yeah, n multiplied by m sine theta minus f1 multiplied by m. Yes, now we need to find the value of this n, right? So here also we have n and this n, so we can combine these two together. So we get the value of n equal to, okay, so if we take this to the other side, so we'll get capital M f2 plus m f1 divided by, so this value, right, so that is m plus m multiplied by sine theta. So that's also, that is our required normal reaction between these two blocks, right? It is similar to the other question that we have done, but the only thing is, so the surface is inclined, okay, making some angle theta with the horizontal, so we have to take the component of the normal force in the required direction, okay, horizontal direction. So that gives you this answer. The normal reaction is mf2 plus mf1 by m plus n sine theta, okay. The normal reaction between the wall and the sphere of mass m given in the figure is. Here the sphere is supported by this wall and this platform, right? So there are 2 points of contact, so there will be 2 normal reactions, one due to the wall which is in the perpendicular direction, right? So that means the normal reaction due to the wall is in the horizontal direction, exactly in the middle, right, passing through the center. And we also have the normal reaction due to that platform, right? So that is also perpendicular to the surfaces, right?
But there is only one point of contact.
Yes, unlike the other questions we have done, here just one point of contact. The surface of the sphere is clearly defined, but the surface of the platform is not defined properly because it is sharp at that point of contact. Yes, now what do we do? So we just find the normal to the surface of the sphere, right? That's all. So at that point, if you draw normal to the sphere, so that will pass through the center, right? So because that is the property of the circle, right? So that's the radial vector. So that passes through the center and it's perpendicular to the curve, right, the surface. So that means you just draw normal to the sphere only, right? So that is the normal, so which passes through the center, okay? So that is the normal force between that platform and the sphere, okay, done. So we have 2 normal forces. Now let us consider the total force acting on the sphere. The sphere is in equilibrium, right? It's not moving anywhere. Right now, what is the total force acting in the horizontal direction? Okay, let us write the total force in the horizontal direction. Yes, so what are the forces? So there is the normal force due to the wall, so that is taken as N1, okay, N1, and also the normal force due to that platform, right? So what is that? That makes angle what? So with the vertical, the angle is theta given. Now with the horizontal, the angle is 90 minus theta, so its component in the horizontal direction is sine theta. You have to multiply by sine theta. Yes, so that is N2 sine theta, right? So that's all. So minus opposite direction, so minus N2 sine theta, so that equals 0, okay? So that's all. So this is the total force in the horizontal direction, so that is 0. Now similarly in the vertical direction, so what is the vertical direction? So this force N1, right, does not contribute to the vertical force, right, because it is already in the horizontal direction, so only N2 has the vertical component, okay? So what is the vertical component? So that is N2, yeah, so N2 cos theta minus mg equals 0, right? Mg is acting in the vertically downward direction and this normal force as component N2 cos theta in the upward direction. So that's also, let's simplify to get the answer. So what do we want to find? So N1, right? We want N1, right? The normal force by the wall, okay? So let us simplify this. N2 can be substituted here. So this gives you our required value of N1. So N1 equals N2 multiplied by sine theta, but what is N2? N2 equals mg divided by cos theta. N2 is mg divided by cos theta multiplied by sine theta. So that's also, this gives you our required value, which is mg tan theta. So that's all. So that is our required N1, which is the normal reaction force between the sphere and the wall, right? So mg tan theta. Okay. If N is the normal reaction between the ground and the block given in the figure, the normal reaction between the rod and the ground is. Here we have a block and a rod placed like this. We have to find the normal reaction. There are three normal reactions, right, between the block and the ground. So that is N. So that is in the vertically upward direction because it is perpendicular to both the surfaces. And similarly, we have the normal reaction between the rod and the ground. But it is just one point of contact, right? But at that point, we can draw normal to one of the surfaces at least. So normal to the ground. So that is in the vertically upward direction again. So N1 is also in the vertically upward direction. We also have normal force between the block and the rod. So that is N2. So what is the direction of N2? At that point of contact, we can draw normal to the rod at least. So that is perpendicular to the rod. So that makes angle, see, the rod makes angle theta with the horizontal. With the vertical, it makes angle 90 minus theta. Then the normal makes angle theta with the vertical, right? So that angle is also theta. So the normal N2 makes angle theta with the vertical. Okay, so these are the normal reactions. We have to find N1 in terms of N, right? So let us write the total force on the block and the rod. Okay, so for that rod, what are the total forces acting on the rod? First we'll write the equation for the rod. Okay, the gravitation force is acting in the vertically downward direction, mg, and the normal force N1 is acting in the vertically upward direction, so minus. So we have taken the downward direction to be positive, okay, and also the component of the normal N2 in the vertical direction, okay, so that is in the vertically upward direction, but making angle what? Theta, okay, so theta cos theta, right, component, right, cos theta multiplied by cos theta. So that means, so in the upward direction, that means minus N2 cos theta. This is the total force, so that must be equal to 0. So this is the equation for the rod. Okay, now we have to write for the block also S. Now, of course, the gravitational force mg in the vertically downward direction, and also the normal force due to the ground in the vertically upward direction, so minus n, and we have the normal, the component of the normal due to n2 in the vertically downward direction, so that is n2, yeah, plus n2 cos theta equal to 0. Okay, yes, that's all. So these are the two equations. Just solve this to get our required value of n1 in terms of n. We don't need n2, so n2 is not asked in the question, so we have to eliminate n2. So what can you do? You can simply add this. Okay, so add these two. We get if you add this, we get m plus m times g minus n1 minus n equals 0. This gives you our required value of n1. So that equals, so n1 equals m plus m times g minus n. So that's it. So that is our required answer. You understand? So whenever there is just one point of contact, not surfaces in contact, point of contact, you draw normal. Okay, you draw normal perpendicular to one of the surfaces. Okay, so that's what we did here. So the normal n1 is perpendicular to ground. Okay, so we found n1 in terms of n. So this is the relation, and that is the answer. A weighing machine reached the mass of a person as 50 kg. If the machine is kept in an elevator moving up with the acceleration 2 meters per second square, the new reading is 50 kilograms is the mass of a person as read by a weighing machine. Now the same reading is taken in an elevator moving upward with some acceleration. So what will be the reading? That's what we have to find.
But the mass of an object doesn't change, does it?
The mass of the person does not change, but the reading might change because the weighing machine does not measure the mass of the person. It only measures the force exerted by the person on the machine. That means it is a normal reaction. Generally, at rest, what is the normal reaction? So normal reaction is same as mg, right? So mg is balanced by the normal reaction. So n equals mg. Now you divide the normal reaction by g, you will get the mass. See, what is the reading? So the reading is simply the reading on the machine, right? So reading equals the normal reaction divided by g. So that is the mass, because what is normal reaction? mg divided by g, so that is m. So that is how the mass of the person is measured by the weighing machine. But the normal reaction is not same when the object is moving, right? See, it's like this on the ground. on the ground, so what is the normal reaction? See, we know that mg minus the normal reaction, that equals 0 because the object is not moving. So normal reaction is equal to mg. So what is the normal reaction here? So mass multiplied by g. So but mass is known, right? So that is 50 kilograms. So 50 multiplied by g, 10 you can take. So 500 Newton. So 500 Newton. Now in the elevator, so let us write the equation, right? Yes. Now this is on the ground. Now in the elevator. So now what are the total forces? The elevator is moving upwards, right? So upward direction is taken as the positive direction. So what is the force acting in the upward direction? That is a normal reaction. So N. Already we have taken N to be the normal reaction in the first case. So let us take it as a N1. N1 is the normal reaction in this case. N1 downward mg. So that is the gravitation force. That equals the mass times the acceleration. This time it is not 0 because there is some acceleration, right? So mass times the acceleration. So now we can find N1. So what is N1? Okay, mg. So mg we have already found, right? So mg is 50 multiplied by this is 500. So that equals, so this is 50 multiplied by the acceleration is given 2. So that will give you N1 value. So N1 is equal to 500 plus 100, so 600. So 600 Newton. So that is the normal reaction in the second case when the object is moving upwards with some acceleration. Now once the normal reaction is found, so now we can write the reading. So what is the reading? The normal reaction divided by g. So that's what we have written here. Normal reaction divided by the acceleration due to gravity. So that equals 600 divided by, so g you can take it as 10. So which means 60 kilograms. So that is the reading given by the weighing machine, right, in the second case. You understand? So the mass of the person increased. The mass of the person actually did not increase, but the reading. So the reading is now 60 instead of 50. It's not the actual reading because the weighing machine is designed to measure the mass of the person only when it is at rest, not when it is moving up with some acceleration. Okay, so this is the new reading. So that is 60 kilogram, right? Okay, so that is the answer. The acceleration of the block of mass capital M given in the figure is. Here we have two wedge shaped blocks. We have to find the accelerations of these two blocks. We have already solved some questions with two blocks, but at that time those two blocks were moving with the same acceleration. They were moving together, but here these two blocks are moving with different accelerations. So the first block, right, that block on the right, so that is moving downwards with acceleration a2. And this block is moving to the left with acceleration a1. a1 and a2 are not equal, right? We have to find the relation between them. Okay, yes, so that is the first thing. So for questions of this type, the first thing we have to do is find the relation between the accelerations of these two blocks. Alright, yes. Now how to find it? So we can do this by two methods. So first thing is using basic trigonometry, simple geometry. See, like this. When that block is moving down with some displacement, okay, so let us find the relation between the displacement. Same is the relation between the acceleration, right? 2 times you differentiate the displacement, we get the acceleration. See, that block is moving down with some displacement, say x2, okay, it has moved by distance x2. At the same time, this block is has moved to the left with displacement x1. Now if you complete the triangle, this angle is theta. Okay, so this angle is theta because so by the basic geometry, so this angle is theta. Now we can find the relation between these two accelerations. So what is that? Simply you take tan theta. So what is tan theta? A2 divided by A1. So tan theta is A2 divided by A1. So A2 equals A1 tan theta, right? So that is one relation. Say tan theta equals A2 divided by A1 from that triangle. So this is the relation. So A2 equals A1 tan theta. So that's all. So this is directly the relation between these two accelerations. Okay. So this is one way of finding the relation between the acceleration. Okay. Another way to find the relation is, see, these objects are moving in different directions, but their acceleration in the direction normal to the surface, so that is same, right? Because those two surfaces are always in contact, right? They are only sliding, so they are not separated, so they are only sliding. That means the acceleration component in the perpendicular direction, okay, for this block and that block, so they are same. What is the perpendicular component of the acceleration? Okay, acceleration of the two blocks in the perpendicular direction. In the perpendicular directions are same. Okay, so this is one idea. So that we may use, right, in the perpendicular direction, perpendicular component of the acceleration, because so in the perpendicular normal direction the accelerations are going to be same because they are always in contact, they move together, so it means perpendicular component of the accelerations are same. See, then what is the perpendicular component of acceleration? So this is the a1. Okay, so a1 acceleration is moving in this direction. Okay, what is its perpendicular component? a1 sin theta, right, a1 sin theta, because 90 minus theta, so a1 sin theta. What is the perpendicular component of the acceleration of the other one? So a2 cos theta, because that angle is theta, okay, with the normal. So a2 cos theta. So these two are same. a1 sin theta equal to a2 cos theta. So that gives you the relation. So what is a2? So it equal to sin theta by cos theta. So a1 tan theta. So this is the relation. Okay, so that is one way to find it. So this can also be useful sometimes, right? So learn both the methods. So a2 equals a1 tan theta. Okay, so we've got the relation between these two accelerations. These two, a1 and a2, may be same if theta is say 45 degree. So if theta is 45 degree, a2 and a1 may be equal. Okay, but generally a2 equals a1 tan theta for this one. Okay, now we'll write the equation. Okay, now so that block, okay, is moving downwards. So what are the forces acting on the object? Obviously the gravitational force, right, the weight is acting in the downward direction, and also the normal force, normal is perpendicular to both the surfaces, the normal is perpendicular to the surface. Now we have to take the vertical component of the normal. Okay, so let us write for the block so let us write for the block small m. Okay, for the block m, so gravitational force is acting in the downward direction, so mg, and the normal force is acting in the vertically upward direction, right? Its component we have to take. So what is the normal component? Okay, so normal is in this direction, perpendicular to the surface. Now we have to take its vertical component. So that normal makes angle theta with the vertical, right? So same angle theta with the vertical. So that means n cos theta. So minus n cos theta. So this is the total force acting on the block in the vertically downward direction. So that must be equal to mass times the acceleration. So mass multiplied by the acceleration is a2, right? So m a2. But what is a2? We've already found the relation between a2 and a1, right? So what is a2? So a1 tan theta. So that can be substituted here. So m a1 tan theta. Okay, yeah. So this is one equation. Similarly, we can write the equation for the block capital. Okay, yes. So what are the forces acting on the block? No gravitational force, because only the horizontal direction we are going to write. So now the component of the normal force in the horizontal direction is the only force acting on this block, right? So this normal force is in this direction. What is the angle made with the horizontal? That is 90 minus theta, because with the vertical it makes angle theta, with the horizontal it makes angle 90 minus theta, which means sin theta. So n normal reaction multiplied by its component, right, sin theta. N sin theta is the only force, so that must be equal to the mass, right, mass times the acceleration. So that is taken as a1. Okay, so that's how, this is one equation. Now we just solve these two equations to get our required answer. We have to eliminate this n now, because n is not required in the question, so we just need a1. So let us eliminate this n1. So this gives you the, okay, this equation I'm writing here. So mg minus this n, so that n can be written from this. What is n? So m a1 divided by sin theta multiplied by cos theta, that equals m a1 tan theta. Okay, so solve this to get the value of a1. Okay, so this is mg minus what is this? This is m a1 cos by sin, so that can be written as cot theta. M a1 cot theta equals m a1 tan theta. Alright, so we can take these two common, right? So a1, so m tan theta, here it is capital M cot theta. So if you divide, you will get a required answer a1. So a1 equals, so mg divided by, so this one, m tan theta plus this value, so m cot theta. Okay, so that's also, that is our required acceleration, mg divided by m tan theta plus m cot theta. Okay, yes. Now, so this is a1. Now if you want a2, okay, the acceleration of the other block. So that can be easily found. You can simply substitute this a1 here. So simply multiply the whole expression by tan theta. You will get the acceleration of the other block also. So that is our required answer. See, this type of question is important, right? Constraint motion, right? The motion of one object depends on the other. So what do we have to do? First of all, we find the relation between the accelerations of these two objects, right? This is one such example. We'll do few more examples of this type, okay? Yes, so this is the answer. The acceleration of the wedges due to the sphere placed on them as given in the figure is. Isn't this question similar to the last one? See, instead of one block moving in the horizontal direction, here we have two blocks which can move in the horizontal direction. So whatever we did in the last question, same logic applies here also. We have to first find the relation between the acceleration of this sphere and these two blocks. These two blocks will move with the same acceleration, right? But in the opposite direction, but same acceleration. But that acceleration should be related to the acceleration of the sphere, okay? So like a1, a2. So let us find the relation, same relation actually, and then you will get the same answer. But instead of one block, we have two blocks here. Instead of m, we may get 2m, right? So that is the only difference. So can you do this yourself?
I can do it myself.
Just check if you get this answer. The acceleration of the wedge given in the figure is. Here we have a wedge over which we have a block, a long block, which is restricted to move only in that direction, right, along its length. So it can only move in that direction, but this wedge can move only in the horizontal direction, right? Now for questions of this type, the first thing we have to do is we will find the relation between the accelerations of these two objects, right? Yes, one depends on the other, but they are not same. So let us find the acceleration. So this wedge has acceleration a2, right? To the left, right, in the horizontal direction. So that block has acceleration a1 in this direction, right, along its length. Okay, now what is the relation? Now we can find this relation using two methods, right, like we did already. See, this is the direction of acceleration of that block, okay, a1, right, in this direction, and then this a2, that is the acceleration of the wedge, so that is in this direction, horizontal direction. Let's complete this triangle. Now this angle is theta, because the wedge, the angle of the wedge is theta, alternate angle, right, theta. So now in this right angle triangle, we can find the value of, say, we can relate this a1 and a2 using that sine theta, because opposite side and hypotenuse, so sine theta. So let us find sine theta. So what is the value of sine theta in that triangle? So that equals, say, a1 divided by a2. So that's it. So this is the relation between these two accelerations. Okay, so done. This can also be done by another method like we did already. Now here you take the component of the acceleration of both these objects in the normal direction. So they should be same. See, like this. So what is the component of this a2 in the normal direction? Right? In the normal direction, the component is a2 sine theta, right? a2 sine theta, because that is 90 minus theta angle, a2 sine theta. So a2 sine theta is in the normal direction. In the normal direction. In the normal direction, the acceleration of this wedge, so that is a2 sine theta, its component, so a2 sine theta. That must be equal to the normal component of the acceleration of that block, but that is already moving in the normal direction only, so that means same acceleration, so that is a1. Okay, so same value, right? So that means a2 sine theta equal to a1, right? So any one method can be used to find the relation between the accelerations of these two objects. Okay, done. Now we got it. Now we write the equation. Okay, now this object, this block is moving in this direction, so let us consider that direction only. So what are the forces acting on that block? Okay, so that block, what are the forces acting on that block? So the gravitational force is acting in the vertically downward direction. Let's take its component in that direction. Okay, take the component. So that angle is theta, right? So theta 90 minus theta is theta. So mg, take its component in that direction. So mg cos theta, right? So that is mg cos theta. So what are the other forces acting on this object? So there is a normal force between this block and the wedge, that is in the opposite direction, so minus n. So this is the total force, right? So that must be equal to mass times the acceleration of the block. So that is mass multiplied by the acceleration of the block is a1. Okay, yes, so that is the equation, but a1 can be written, a1 equals a2 sine theta, so that can also be written, so this m a2 sine theta. Okay, so this is for that block. Now for the wedge in the horizontal direction. What are the forces? We don't consider gravitational force because that is in the perpendicular direction. So leave it. Now only the normal reaction. So normal is in this direction, right? In this direction. Take its component in the horizontal direction. So this is the normal reaction in this direction. Take its component. So what is that angle? So that angle is 90 minus theta. So that means sine theta. So this is for the wedge. Yeah. 90 minus theta, right? That means sine theta. So that is n sine theta. So this is the normal component in the horizontal direction, and that is the only force in the horizontal direction. Okay, yes. So that must be equal to mass times the acceleration of the wedge. So that is A2. That's all. These are the only two equations. Let us solve these two to get the value of A2. But what do we have to eliminate? N, right? N is not required. So let us eliminate N from these two equations. So find the value of N, substitute here. So this gives the relation between this mg cos theta minus N. But that N can be written from this. So minus N. What is the value of N from this? Ma2 cosecant theta, right? So taken to the other side, right? Actually N equals Ma2 divided by sin theta, so that is Ma2 cosecant theta, so that is N. Okay, so that must be equal to Ma2 sin theta, so that is the right hand side. So we are writing this equation is from this, right, after substituting the value of N. Okay, so that's all. So this will give you A2 value. So our required A2 equals, this is mg cos theta divided by, so this one, right, m sin theta plus capital M cosecant theta. Okay, so that's all. So this is the acceleration of the wedge, right? So that is A2. Suppose you want to find the acceleration of that block, you can substitute that, right? We got the relation. So A2 is known. If you substitute A2 here, we'll get the value of A1 also. Just multiply by sin theta, right? So but we just need the acceleration of the wedge. So that is this one, mg cos theta divided by m sin theta plus m cosec theta. So that is the answer. Okay. The rod AB is leaning against a wall. The relation between the velocities of the two ends of the rod when it makes an angle theta with the horizontal is. Here a rod leaning against a wall is slipping. That means the position of the point B, right, one end of the rod. So that is lowering. That means it's coming down, and the other end A is moving in the horizontal direction, right? Now what is the relation between the velocities of these two endpoints, right, A and B? Not same, right? So there must be some relation between these two velocities. So we have to find that thing. See, let us consider this right angle triangle, right? So this is Y, this is X. X and Y are variables, right? But when Y decreases, so B also lowers, right? That means the rate at which Y decreases, that is the velocity of the point B, right? Y decreases, so velocity of B, right? That is the rate at which Y decreases is the velocity of B. And similarly, the rate at which X increases, so that is the velocity of A, right? Because as X increases, the point A moves. Similarly, Y decreases, the point B moves down, right? So that means the velocity of the point B is the rate at which this Y decreases. That means, so we can write the velocity of B to be the rate of change of the value of Y, right? Yes. Now that rate of change is denoted by dy by dt. Okay, minus, right? Minus, because Y decreases actually. Y decreases, but X increases. So that means the rate of, so VA. So VA equal to the rate of change of the value of X, right? X increases, the position of A changes. So that means the rate at which X increases, so that is the velocity of A. Similarly for the point B. Okay, so this is the relation. Now this is a right angle triangle. Now these are not constants, X and Y are variables, but what is constant? The constant here is the length of the rod, right? Length of the rod L, so that is fixed. That means the hypotenuse of the triangle is fixed, but these two sides of the triangle are not fixed. So we have the Pythagoras theorem, right? So x square plus y square, so x square plus y square is equal to the length of the rod, so L square. Okay, now you do the differentiation here. So this is a constant, so what is the derivative of this? This is 2x with respect to time only, so dx by dt plus 2y dy by dt, so that equals 0 because it's a constant, so that is 0. So that's all. This is the relation, but we know that dx by dt is equal to, right, so dx by dt is the velocity of the point A, so that means this is x multiplied by the velocity of the point A, so plus similarly this one, after dividing by 2, dy by dt is negative of the velocity of the point B. so that equals 0. So this is the relation. So velocity of B equals, okay, so that is minus, okay, plus x by y velocity of A. So that's all. So this is the relation, but x and y are not known, okay, but instead theta is given. Theta, that right angle triangle, what is theta? If you take tan theta, so what is the value of tan theta? So that is opposite, y divided by x, but here we have x divided by y, so that is the reciprocal. So cot theta, so VB equals VA multiplied by cot theta. So that's all. So this is the relation between these two velocities, right? See, this question is nothing to do with the force or acceleration. So no acceleration, no force, right? No Newton's law, nothing. Simply to find the relation between the velocities of two endpoints. So it is a constrained motion, right? So the motion of one depends on the other, but not exactly equal, but one depends on the other. What is the relation between the motion or the velocities of these 2 points? That's what we are finding. So this is the relation. Now there is one more idea we use here to find this answer, right? Instead of using the derivative method, see, the velocity of the one end of the rod, that is B, the velocity of the other end A. So these two velocities are not same because the rod is rotating. Suppose the rod is not rotating, it is just moving horizontally like this or vertically, any direction, it is just moving, right? Translational motion. In that case, the velocity of B and velocity of A will remain the same, okay, no change. Because the rod is rotating, right, it is slipping, so that means it is rotating, so that is why we have different velocities, okay, yes. Now, if the rod is rotating or moving, whatever it is, the component of these two velocities in the direction, right, along the length of the rod, so that should be same. Right, so what is the component of the velocity? The velocity of B is in the vertically downward direction. What is its component along the length of the rod? Right, along the length of the rod. So that angle is 90 minus theta. So that means VB sin theta. Okay, so the velocity components of both the ends are any point. Velocity components along the length of the rod, along the rod. So for this point, what is the velocity component? For that point, it is 90 minus theta, that means VB downwards, and then 90 minus theta, that means take its component, that is VB sin theta. That is one end. Similarly for the other end. So this moves in this direction, take its component, this angle is theta only, right? Because that's the same angle, right? Theta. So VA cos theta. So VA cos theta is the velocity component of A in the direction along the length of the rod, right? That means it is VA cos theta. Okay, so that gives you our required answer. So VB equals VA multiplied by cos theta divided by sin theta. So that can be written as cot theta. So this is also one way to do it. So we can generalize this also. Take a solid body, right? So this object is rotating or moving, whatever it is. There are two random points, right? These two can be any points on this object, right? So A is one point, B is one point. But these points do not have the same velocity, not necessarily. If the object is rotating, they don't have the same velocity, right? That has some velocity and this has some velocity in different directions. But you take the component of the velocity along the line joining these 2 points, right? The line joining A and B, right? This is a line. Now you take the component of this velocity of B in that direction, right? So VB theta 2, VB theta 2. That is a component in the direction joining these 2 points. Yes. Now similarly, you take the component of the velocity of this point along the same line. So that is VA, right? So VA cos theta 1, right? VA cos theta 1. So VA cos theta 1 and VB cos theta 1, cos theta 2 are equal. The velocities are different, okay? But the components of the velocity along the line joining them, they are equal, right? That means VA cos theta 1 and VB cos theta 2 are equal, right? So this idea can be used in many questions, right? So keep a note of this thing. So velocities may be different at different points if the object is rotating, but take the components along the length, okay? So along the line joining these 2 different points, these velocities will have the same value, right? So we use that idea to get the answer also. This is also another way to find it using differentiation. So for that, there must be one constant value. What is the constant value here? That is the hypotenuse. So with the help of that, we relate the other 2 sides, right? The variables are x and y. We relate them using that constant value. After that, differentiation will give you the answer. But this method is also important, right? So remember this method also to find the relation between different points, the velocities of different points of that object, right? Yes. So that's all. So VB equals VA cot theta. Okay. The relation between the velocities of the ring B and the block A given in the figure is. Here a block A is suspended by a string. This string goes through a fixed ring and the other end is connected to a moving ring. So this ring can move up and down, right, in the vertical direction. The block can also move in the vertical direction, right. Now we have to relate the velocities of these two objects, right. So that block and this moving ring, right. What is the relation between the velocities of these two objects, right? Yes. Now here let us take that distance to be x, right, the position of that block from the topmost point, right, that length is taken as x. Similarly for that ring, moving ring, so that position is y below that topmost point. Okay, yes. Now we have to relate these velocities. Now as x increases, the block A changes position. That means the rate of change of x is the velocity of A, right. So that means the velocity of A here is the rate of change of x. So dx divided by dt. As x increases, the position comes below, right. So it moves downwards. So that means the rate at which x increases, that is the velocity of A. Similarly, as y decreases, the position of B so moves upwards, right. That means the rate of change of y. So that is the velocity of B, but y decreases. So that means the velocity of B, so that equals minus dy divided by dt. Okay, just like the last question. Now here these two are variables, x and y both are variables, but what is constant here? See, one constant here is the length of the string, right? The length of the string, the total length of the string is constant. So what is length of the string? So the portion of the string, so that is x below that topmost point, and also between these two rings, so that portion has length L minus x, right? Because the total length of the string can be taken as some L, constant. L is constant. So already x is gone, so here this remaining portion, right, the in between these two rings we have that length L minus x. So L minus x is that length. Okay, and y, and also we have one more constant, so the length of the rod, right, in the horizontal position, right, that is also constant. We can take it as some c. Okay, so these are all constant. X and y are variables. Let us relate them. Again we have a right angle triangle here. It is again a right angle triangle. Use Pythagoras theorem. Yes. So what do you get? So y square plus c square, so that equals L minus x square, right. In that right angle triangle we have this relation. Now you differentiate. So differentiate this. So 2 y dy by dt plus c is a constant 0, so that equals, so 2 multiplied by L minus x, and its derivative is L is constant, so minus dx divided by dt. Okay, so that's all. So that is the relation. But what is dy by dt? So that is yeah, so 2 can be cancelled, so this is minus y, velocity of the point B. So that equals, this is L minus x and minus dx by dt. So that is minus velocity of A. So that's all. This is the relation. So VB equals, so L minus x divided by y multiplied by the velocity of A. Okay, now L minus x divided by y in that right angle triangle. So we got the angle, right? The angle is theta. So now what is L minus x? L minus x is the hypotenuse of that right angle triangle, and y is the adjacent side. So hypotenuse divided by adjacent side, that is, right, adjacent side by hypotenuse. So that is cos theta, right? But here it is a reciprocal. So that means it is secant theta, right, multiplied by VA. So that's all. So this is the relation, VB equal to VA multiplied by secant theta. So that's all. So that is the relation. Now like we did in the last question, here also we can do it by the method. See, we can find the velocity of these 2 points A and B along the string. Okay, along the string, because the string is going to move in the same direction, right? So now we find the velocity of the point A and velocity of the point B, the components of these velocities along the string. They will have the same value, right? Just like the last one. There it is a straight line. It's not a straight line here, but along the string you find the velocity. Now what is the velocity of the point A along the string? The point A is already moving along the string only. As the string, right, that is the length of the string. It is moving vertically downwards. The string is also moving in the vertically downward direction. So the velocity components along the string, okay, the velocity components along the string for both the points, so they'll have the same value, right? So what is the velocity component of A along the string? So that is the velocity of A itself, because the string is also moving in the vertically downward direction. The point A, right, or the block A is also moving in the vertically downward direction. So that is same as velocity of A only. Okay, but Here, this point B is moving in the vertically upward direction, but string is making some angle theta. So we have to take its component VB in the upward direction. So we have to take its component, right? Theta. So that means cos of that angle. So that means that is equal to VB multiplied by cos theta. Okay, so this is the relation. So is it same? So VB equals, right, VA multiplied by secant theta. Yes, so this is also one way to find the answer. You understand? So that's all. See, these questions are nothing to do with the Newton's law or anything. So only to find the relation between the velocities we found, we've used this method, right? So it's a constrained motion, right? So the motion of one object depends on the motion of the other. So we have to use all these ideas to find the relation. Okay.
Can we differentiate to get the acceleration?
Yes, if you differentiate the velocities, we get the acceleration. You differentiate both the sides. So velocity, if you differentiate, we get the acceleration of the object A. Similarly, acceleration of the object B. But this cos theta is not constant. You can't leave it as it is, because as x and y changes values, so theta will also change, right? It is also variable. So when you differentiate, this is acceleration at the point A. When you differentiate this, you get the acceleration at the point B. And then this also we have to differentiate. For that we have to use product rule, right? So this multiplied by derivative of cos theta, which is minus sin theta, and cos theta multiplied by derivative of VB, that is the acceleration at the point B. You understand? We will not directly get the relation between the accelerations of these two objects, but that is related through the velocity also, right? So if you want to write this, so this is the differential. So if you differentiate, so the velocity, if you differentiate, we get the acceleration of the object A. So that equals, so if you differentiate this, that is acceleration of the point B multiplied by cos theta as it is, plus this multiplied by derivative of this. So the velocity of B multiplied by, so the derivative of cos theta, so that is minus sin theta, right? So we relate accelerations of these two objects in terms of the velocity of the point B, right? So not directly accelerations are related, right? So in terms of the velocity, we have to write the relation, okay? But here the velocities of these two objects are directly related, okay? This is the relation. Keep in mind, this cos theta is not constant, it is a variable, okay? But anyway, for this question, this acceleration is not required. We just need the relation between the velocities. So that has value, this one. So VA equals VB cos theta, okay? Yes. A bead can freely pass through a wire in the shape of a parabola y equal to kx square. Initially, the bead is at the bottom. If the wire is displaced horizontally with acceleration a, how high the bead rises? Here we have a wire in the shape of a parabola, right? The equation of that parabola is also given y equal to kx square, right? There is a bead which can move along this wire, right? So initially when the parabola or the wire is at rest, now the bead stays at the bottom, right? So here at the bottommost point, right? Now when the wire starts moving with some acceleration in the horizontal direction, this bead will try to move backwards, right, with respect to the wire, right? And it gets lifted up, right? How high does it rise? Which means we have to find the y coordinate of the point at which this lies, okay? So y coordinate, right, that is the height, right, that we have to find, okay? Yes. Now let us write the equation. This wire and also the bead, so both are moving with some acceleration a, right? Then what is the equation of motion? Let us write the equation, right, for that bead, okay? So what are the forces acting on the bead? So there is a normal reaction between this bead and the wire, right, in the perpendicular direction. So this normal is perpendicular to that wire, right? At that point the normal is perpendicular to the wire. Now we have to take its horizontal component, because the object is moving in the horizontal direction. Take its component, take this angle to be theta with the horizontal. That means what is its component? N cos theta, right? N cos theta, that is the only force acting in the horizontal direction, right? N cos theta on the bead, right? So N cos theta is the force in the horizontal direction, N cos theta, okay? So that must be equal to mass times the acceleration, okay? So that's it. So this is the equation for that bead, okay? Yes. Now how to find the value of N, right? So we have to find the acceleration, right? To find the acceleration, so we need cos theta and also we need the value of N, right? Yes. Now in the vertically downward direction, so this is the horizontal direction. Now vertically downward direction, okay? So this is the horizontal direction, and now the vertical direction. In the vertical direction, the object is not moving, the bead is not moving, it is only moving in the horizontal direction. So the total force in the vertical direction, that must be 0. So what is the force? Mg in the vertically downward direction, yes, Mg. And also there is a normal reaction whose component in the vertically upward direction is N sin theta, because this angle is theta, 90 minus theta here. So N sin theta in the vertically upward direction, opposite direction. So minus N sin theta. So that must be equal to 0 because no vertical motion. Okay, yes. Now, so we can just substitute here to get the value, or we can divide this. So we'll get n cos theta divided by n sin theta. So we get the value of, say, tan theta. So tan theta equal to, so here sin theta by cos theta, right? mg divided by ma. So which is g by a. Okay, so we've got the value of tan theta. Okay, now we'll also find the value of tan theta using some other method, right? So we have to use some kind of a mathematics here, right? So the derivative of the function, we have to find the derivative. So what is the derivative? The geometrical meaning of derivative, that is the slope of the tangent at that point. But we have this tan theta which is slope of normal, because normal makes angle, normal means the perpendicular line makes angle theta with the horizontal. So this tan theta here is the slope of normal. Okay, slope of normal. Let us find the slope of tangent. Okay, slope of tangent. Slope of tangent. So that has formula. So this is the formula for slope of tangent. Simply the derivative of the function, right? Derivative of the function at that point, right? So dy by dx. So that can be found because the function is given y equal to kx square. So that means the derivative here is equal to 2kx, right? That is the derivative of the function. Okay, so that's it. That is the slope of tangent. But that is not the slope of tangent, this one. This is slope of normal, right? So tan theta. Now we have to find the slope of tangent, right? So how to find it? Slope of normal. See, we know that when two lines are perpendicular, the product of slopes equal to -1, right? So this is tangent and normal. These are perpendicular. So their slopes are m1 and m2. So the product is -1. So this is slope of normal. Then what is slope of tangent? So -1 by m2, right? So that means the negative reciprocal of this thing. So that means it is minus a by g. Okay, so minus a by g is the slope of tangent from this, and we also find the slope of tangent by some other method, right? Using the derivative. By two methods we found the slope of tangent. One by this slope of normal and one by using the derivative. Okay, so we got it. So this will give you the value of x. So what is the value of x? So this gives you the value of x minus a divided by 2kg. So the x value is found. Now what x value means, what? The x coordinate of that position of that bead, right? X. Now we have to find the y coordinate, right? Y is what we need. Okay, so y value, that is the height, right? So y, you can substitute this value of x in the given equation, we'll get y value. So y is equal to kx square. So y is equal to kx square. So x square is the square of this minus a divided by 2kg square. So that equals, yeah, so simplify this, you will get our required answer, right? So 1k gets cancelled. So this is a square divided by 4kg square. So that's all. So this is the y value, that means the height, right, to which this this bead rises, right? So that is our required answer, a square divided by 4kg square. Okay. A man is standing on a wedge placed on a smooth plane of inclination theta. The acceleration of the wedge is. Here we have a wedge placed on an inclined plane and someone is standing on the wedge, right? This system is sliding on the plane. Now we have to find its acceleration, right? So there are two objects we have to consider here, that wedge and that boy, right? So let us consider these two, right? So this wedge, what are the forces acting on this wedge along its motion? So there is a normal reaction, right, in this direction, perpendicular direction. We don't consider that thing. So we only consider the equation in the direction of motion. So what are the forces acting in that direction? The gravitational force is acting in the vertically downward direction. We have to take its component. Okay, so one thing, gravitational force. The other force is the man is standing on this wedge. That means there will be a normal reaction due to this person, normal reaction in the vertically downward direction. Alright, these are the two forces acting on the object, right? So let us consider that. So this is for the wedge. So gravitational force is acting in the vertically downward direction, but we have to take its component. What is the direction it makes with that plane? Inclined plane. So that is 90 minus theta, right? Because this angle is theta, right angle triangle, this is 90 minus theta. That means sine theta. So mg sine theta. So that is the, yes, mg sine theta. Mg sine theta is the component of the gravitational force in the direction of its motion. Okay, and also the normal force is acting in the vertically downward direction. We have to take its component also. So what is the component? Again same thing, right? So sine theta. So m sine theta plus n sine theta. So total force is this, and that equals mass times the acceleration of the okay block. So that is taken as am. Okay, yes. Now this is the equation for that block. Okay, for that wedge. Now for that person. Okay, for that person Okay, so that man or this boy. Okay, now what is the equation in the vertically downward direction? This time we consider the equation for the vertically downward direction. He is actually moving in the vertically downward direction. What is this? What are the forces acting on him in the vertically downward direction? He is applying a normal force on that wedge. So wedge will also apply a normal force in the opposite direction, vertically upward direction. So mg in the vertically downward direction. So mg in the vertically downward direction. Mg. And normal force in the opposite direction. So minus n. So this is the total force. That's all, right? These are the forces acting on that man, and that must be equal to mass times the acceleration. Mass times the acceleration of m. But this is the acceleration in the vertically downward direction, like this, am. But the wedge is moving in this direction. Am is the acceleration of the wedge. So am, right? So this is am. So what is the relation between them? So we know that this angle is theta. So this angle is theta. So that means if you take sine theta, so that is am divided by am. So that means, so if you take sine theta, so sine theta equals am divided by am. So we can write this am in terms of the acceleration of that wedge. Okay, so this equals, so mass multiplied by the acceleration of this, that is am sine theta. Okay, so that's also, these are the two equations. We can solve them to get the value of am. Okay, this n is not required. So let us find this value of n and then substitute there. So we'll get the required answer. So what is the value of n here from this? So this gives you the value of n. So n equals mg minus m sine theta multiplied by am. So this can be substituted in the first equation. Okay, so that gives you our required value. So mg sine theta plus n, but that n is this one, mg minus m sine theta am, okay, multiplied by sine theta, that equals m times am. Okay, so you find the value of am from this. So here also we have am and am, so if you combine them, so we get am equals, okay, so other terms can be written here, mg sine theta, and then here plus mg sine theta again, this one multiply, so mg sine theta divided by, so this value you have to bring this term to the other side. This is m sine square theta, so here am, so that means if you bring it to one side, it is m plus this one m sine theta, so that is sine square theta, so m sine square theta. Okay, so that is the answer, right? So mg sine theta plus small mg sine theta divided by m plus m sine square theta. So that is our required acceleration of the wedge. Okay, yes, so that is the answer. Okay. So we are done with normal reaction. In the next class, we'll talk about the tension force. Okay.